So let me now summarize all these motivations. The first motivation was that design codes, they lack explicit performance check, right. This leads us to an alternate design philosophy which allows us to explicitly check what damage is going to happen to my building in case of what level of an earthquake, right. This is what PBD will do actually, that explicit performance verification which is lacking in the traditional building codes. So it requires the designer to assess how a building is likely to perform in extreme events, and their correct application will help to identify unsafe designs. So all those cases where the performance was still not acceptable even after following the provisions of a building code, those cases will be clearly identified if you use performance based design, right. And it also enables arbitrary restrictions to be lifted and provides scope for the development of innovative, safer and more cost effective solutions. So performance based design is an alternate technology. Think of it as a new technology which if you can adopt, you will be able to develop more cost effective designs, because it will focus directly on the building performance and not following on a particular provision or you can say requirement of a traditional code, right. So you can start with a basic design which can be done by following a particular building code, and then explicitly check the performance of that design using performance based methodology, right. If a certain performance requirement requires you to go against a particular provision of a building code, you will do that under certain limitations and under certain requirements and approval from the authority having jurisdiction, right. So performance based design gives you that freedom actually to go for innovative geometries, innovative materials, innovative forms, right, still having cost effectiveness in your designs. So in 1980s and 90s, as I have stated in start also, that in the prevailing era of building codes, the owners began to question how their buildings would perform in future earthquakes and demand that engineers design or upgrade their buildings to perform better. So the owner actually sets a performance objective, right, and that may be different from the intention of a building code, which is life safety. Owner may say that I want to go beyond life safety, my structure should remain completely operational at the design level earthquake. I want to go beyond life safety. This requirement that it should remain operational is a performance objective which is set by the building owner for the structural designer. Now you are free to use any design method, any analysis procedure, but you have to just follow that requirement. Unless you fulfill that performance objective, which is no downtime or completely operational during the design earthquake, unless you follow that, you are okay, right. So the owner usually express their design in terms of a series of performance objectives, and as I just give you one example, there can be several performance objectives. I want my existing building to be safe under this earthquake. I want to be able to see my building right away, to use my building right away. It should remain operational. After an earthquake, it should be directly occupied again, right. So I don't want to allow even any non-structural damage. This can be one performance objective set by the owner. I want the repair cost to be less than 20% of the replacement value. This can be one requirement. This can be one performance objective. And there can be performance objectives in terms of social losses also. I don't want anyone to get injured in case of this much earthquake, right. It can be related to downtime, it can be related to replacement cost, repair requirements, damage to a particular structural component. It can be related to anything, not only cost and damage, and it can be related to anything. and you are required to fulfill that requirement. This is what PBD allows you, right? So, it is an approach in which the structural design criteria are expressed in terms of achieving a set of performance objectives. Performance objectives. When a particular performance objective set by the client becomes your design criteria, it is called PBD, right? And that performance objective can be anything. I give you a few examples in last slide, right? So, you will use all of your experience and energies and you can say efforts, analysis, design, everything, knowledge, everything, just to fulfill that requirement, because that requirement now becomes your design criteria, right? So, this is in essence what is performance based design, that the structural design criteria is not expressed in terms of following a particular building code, it is expressed in terms of fulfilling a particular set of performance objectives which are agreed upon between client and structural designer, right. So, it means that the very first step of PBD is to have a consensus on what will be our performance objectives, right. What actually you want me to do actually as a design criteria, right. So, we start with conventional code based design, but then we use the additional performance objectives as our design criteria in this approach. But obviously, if you want to explicitly verify the structural performance, it may not be you can say possible using linear analysis. You have to go to nonlinear analysis if you want to see what damage is going to have to your structure under a certain level of an earthquake, because a nonlinear computer model will have the capability to tell you that what element is going to get cracked or what element is going to yield after the analysis. A linear analysis will always follow Hooke's law, F is equal to Ku. So, that model will not have any capability to tell you the structural damage, and it means that if you apply unrealistically high force, the structural model will give you unrealistically high displacements, and then you have to yourself you can say interpret the results, whether those displacements are really possible or not, whether your structure is going to sustain those displacements or not, right. But on the other hand, a nonlinear analysis and nonlinear computer model will have the capability to simulate all the damage limit states, for example, right. So, which means that if you want to apply performance based design, you have to learn nonlinear analysis and nonlinear modeling, right. So, you have to go beyond the building code. Building code always recommend linear analysis and linear modeling, and in PBD you have to go beyond that. So, when you set the performance objectives as your design criteria, you have to actually link the performance and earthquake hazard in an explicit manner. You will be able to link them explicitly. For example, you will be able to tell that at this much hazard level, this much earthquake level, what will be the performance of my structure, unlike the traditional code based design where you cannot answer this question, right. So, it ensures that the structure reaches a particular performance level, and this alternate seismic design philosophy is required when the traditional codes are not suitable or not applicable to some structural systems, and explicit verification is not specified or required in most codes. Therefore, you want to go to PBD. And then most importantly, public at large, they does not care about what code we follow or what analysis procedure we actually use. All they care is about safety and performance. They have direct questions from us: will our structure be able to survive a particular earthquake, or what is the repair cost, what will be the downtime, and will it be safe or not, lastly, right. So, these are the questions which performance based design kind of allows you to answer in certain limitations, but Obviously, you will not be able to exactly give the warranty of your structure, but certain meaningful discussions can happen if you agree with the client about a particular performance objective. So, client tells you the performance objective and you just use all the knowledge and expertise and efforts to fulfill that objective. So, in a sense, there are you can say direct conversations or transfer of knowledge and concepts and opinions. They can share their experiences in a common language, which was not possible actually if you follow the building code, which with a fixed intention. So, another example of how the prescriptive approach and the performance based approach differs. If I, for example, want to go for prescriptive approach and my target is to get a concrete of 21 megapascal strength, actually a prescriptive approach will specify the mix design, and implicitly it will ensure that the resulting concrete will have a strength more than 21 megapascal. On the other hand, if you go for performance based approach, the emphasis on the key performance indicator. So, the emphasis is that you have to come up with a concrete which have strength more than 21 megapascal. Concrete less than 21 megapascal is rejected. So, you are free to use any method or any recipe which ensures that 21 megapascal. So, this is an example of how the requirement is prescribed in prescriptive manner and in the performance based manner, right. So, I will end on this maybe point that the essence of PBD is what? That a decision maker states a desire that a building be able to perform in a certain way. That desire or that performance objective can be anything. It can be based on the protection of life safety, minimization of the potential repair cost or disruption of use, for example. The engineer uses his or her skills to provide a design that will be capable of achieving these objectives, right. This is the summary of performance based design or essence of performance based design, that the owner's desire, client's desire of the performance becomes your design criteria, right. And obviously, in order to ensure or fulfill that requirement, you have to go beyond code. If you are a traditional structural engineer which only knows linear analysis and linear modeling, you will not be able to fulfill that requirement, right. So, the performance objective is a combination of two things. One is the requirement itself, a performance level, we call it performance level. It is the maximum acceptable level of damage given that the ground motion occurs. This level is set by the client for you, right. It is something which is acceptable for him, but this should always be accompanied with the ground motion hazard, right. I mean, the complete performance objective can be like, I want no damage in my columns and beams at this much level of hazard, right. So, it should be always accompanied with the level of hazard, right. It is not that no damage for all the cases. It should be at this much level of hazard, I want no damage in my concrete walls and, for example, columns and beams. But at a higher level of earthquake, I may allow some cracking, right, because a higher level is a rare earthquake. So, there is a possibility that I may never experience that higher level. So, in order to make a structure completely elastic against that higher level will not be a wise decision, right. So, if there is an earthquake which may never come in the design life of an earthquake, which is that rare, then you may allow some damage in case of that earthquake in order to make the design more economical, right, cost effective. So, the performance level is always accompanied with the ground motion level, and this makes your performance objective, right. So, let me give you a few examples before we end. I don't want any cracking in my masonry infill walls at a frequent level or a low level earthquake, and I have to define what I mean by a low level earthquake. That I will explain maybe tomorrow, right, how the seismic hazard is quantified in performance based seismic design. It is quantified in probabilistic manner, not in the deterministic manner. So, I will define earthquakes in that framework. So, for this discussion I can set one performance objective, that at a low level earthquake, which is a frequent earthquake, I may not allow any cracking in my infill walls, but at a moderate level earthquake, quote unquote, I have to define what a moderate level means. I can allow some minor cracking in the infill walls, right, and at a very severe earthquake, which is very rare to occur, I may allow a complete damage of my masonry infill walls, some cracking in my concrete beams and columns, but the structure should remain standing, it should not collapse. So, all these statements, each one of them is a performance objective, right. Performance objective can be this also, that at severe earthquake I do not want anyone to get injured, or I do not want any casualty at moderate level earthquake, or I want repair cost to be less than this much dollars at this much level of an earthquake, right. So, it can be these statements, any of these statements. So, first the client and structural engineer, they agree on these performance objectives, right, and then he does not care which code you follow, which procedure you follow, which design methodology you have followed, right. So, we will continue this discussion tomorrow also. There is a process called peer review in performance based design, that also I will cover in one of the lectures. Peer review is an essential requirement in performance based design. It is not that the performance based design engineer gives you a one design and that is final. It is mandatory in PBD to have a third party peer review, that should be from another performance based design expert, right. So, exactly to address this point, this process is essential, it is considered mandatory in the PBD, right. So, just like the conventional code based design, we have a vetting process. Obviously, there is a big difference between the conventional vetting and peer review of the PBD, but similar to that, you can say that once you have a complete performance based design, nonlinear analysis, all the requirements are fulfilled, then you have a peer review from another expert or a team of experts, right. So, this is inherently, it is built in this PBD model. Actually, the stability certificate which you are mentioning is code compliance certificate, right. So, if some building for which you have given that stability certificate, unfortunately if it just fall down and you are asked to explain that, for example, all you need to do is to prove that you followed that building code, right. You do not need to explicitly verify that according to my calculations the building's performance was not like this, or it was safe at that time. You do not need to do, all you need to do is to show or prove that you followed that code which was applicable there at that particular site, right. Yes, obviously, if you go beyond building code, you explicitly verified the performance, then you can more confidently answer those questions which I mentioned in the start, right. In our local context in Pakistan, currently this there is a whole regulatory body which regulates the conventional structural design. There is a system in place. For performance based design, unfortunately we do not have such system in place which recognizes that this is an alternate design philosophy which should be actually you can say checked based on these requirements or set of rules. For example, they don't exist in our local context, but in other countries where this methodology has become a routine for important structures, they have a legal framework also associated with that, right? So in Pakistan, if someone wants the performance based design for his building, currently primarily it was not because that there is a requirement from the building development authority on him, it will be only because that he may want more information or more safety in his structure, or maybe one, you can say, primary motivation for PBD can be the cost effectiveness also, because if you apply the conventional seismic design philosophy which is meant for low rise buildings, when you apply it for a 50-story building, same philosophy, you will end up in a very you can say uneconomical design. So, and in certain scenarios you don't have any other option but to go to PBD, right? This question is related to trigger for retrofit. Just check that trigger for retrofit, that what actually is what can actually cause for a building owner to consider retrofitting, right? It can be some apparent damage, it can be a radical change in the seismic design, seismic hazard level at a certain area, it can be any other reason also. There can be several reasons which can trigger the need for retrofit. Let me give you one example. Bangkok was considered long time that it is free from major earthquakes. It is not close to any of the major seismic sources, but there are several recent studies which highlighted that this city may still be at risk from certain damaging earthquakes, and one of the reasons is that the soil on which the whole city is resting is loose soil deposit, and it has the ability to amplify the ground shaking 3 to 4 times. So even a low to moderate level earthquake can cause significant damage, it can be amplified and cause significant damage. So this is an example of a place where the understanding about seismic hazard have suddenly changed in a matter of few years. So if we have some improved understanding of the hazard, previously we thought that it is not that high level hazard and now we have high level, then it may serve as a trigger for the need of retrofit. Any apparent damage or deterioration can be used as a trigger for retrofit, right? So there can be several reasons. There is a proper setup about the routine checking of the existing building stock, right? And wherever there is a need for a particular retrofit or detailed evaluation, obviously there is a mechanism placed for that. Please check ASCE 41 document, which is the seismic rehabilitation of existing structures. It actually prescribes a 3-tier process. First tier is for all buildings, then you identify any deficiencies, you narrow down your scope, and then check some more detailed for few structures which require that evaluation, and finally tier 3 means a very detailed evaluation for the retrofitting, right? So generally the overall building stock is surveyed or is checked after certain years